2.4 is about adding and subtracting polynomials, but we're not going to subtract until tomorrow. I found in previous years, even though students think this is easy, and they're kind of like, I don't know why we're taking this so slowly. I have found that if I don't, we aren't as successful with it because we think we know what we're doing, and we don't take enough time with them, and then we combine things incorrectly. So we want to make sure, because it's going to be important, especially when we start multiplying polynomials, that we know how to add and subtract properly. Okay, so in our adding and subtracting monomials, which is, what we're going to start with here. We just have monomials that have addition and or subtraction signs between them. We're going to identify our like terms, rearrange putting those terms together in the order, and we're going to combine like terms. Now in the process of rearranging them, we already know about standard form. And typically, most of the time, they give the answers in standard form. They're not going to give them, typically, in non-standard form. So we're just going to get used to when we can put them in standard form, when there's only one variable involved, especially, we're going to, as we're rearranging, think about standard form. So in this first one, we have 3 monomials being added. Can we add any of those? Which ones? First two. And is this already in what we would call kind of standard form? We just need to simplify it, right? So what do we end up with?
5x squared.
5x squared plus x. All we're doing here is what we just practiced a couple of days ago. Are you ready? Can you combine like terms? That's really what's happening here. Okay, so would this be considered in standard form? A polynomial in standard form? What do you think?
Yes.
Yeah. What's the leading coefficient then?
5.
5. What's its classification? What's its name? It's a degree 2, so it's quadratic, and it's got 2 terms, so it's a binomial. So this would actually be considered a quadratic binomial. Okay, the next one. Let's change any subtraction we see to add the opposite, because until you're really masters at this is how we're at least going to practice together. So we're going to take our subtraction and change it to add the opposite, because once it becomes it becomes all additions, then what property allows us to rearrange it? Starts with a C. Commutative property of addition allows us to add in any order we want. So we're going to switch it up so that we are, in standard form, would the z to the fourths come first or the constants?
Z to the 4th.
The z to the fourths. Okay, so let's write down that we're going to bring the z to the fourths to the beginning of our polynomial and the constants behind them. And then we see, we've got some z to the fourths here that are going to become what? 20 of them. There are 4 and 16 more, that's altogether 20. We're adding, they stay z to the fourths. Get that planted in your head, when you're adding things, they stay what they are. There just becomes more of them, or maybe less of them if there was a negative involved. And then, because when we multiply, things are going to change. And then what do we have for when we combine our constants? What do we end up with? Negative 6. Do you suppose that's how we would see that in an answer bank? How would we see it in an answer bank?
20z to the 4th power minus 6.
Yeah, we clean it up to be 20 z to the 4th, take away 6. There would be our final answer. How it should show up in an answer bank. Okay. So, any questions about that one at all? Okay, well notice what's different about our next one is we have a couple of different variables involved in it. So when there's a couple of different variables involved, how would they typically show the answer then? What else does algebra like?
Alphabetical.
Alphabetical order. It likes things in alphabetical order, so we're going to keep that in mind. So let's first of all change our subtractions that we have to add the opposite, and maybe even insert some 1s in there. So they'll subtract, and that's really a 1x cubed, becomes plus a negative 1x cubed. Subtract y cubed, really a negative 1, or it's a 1y cubed, that means that we're going to change it to plus a negative. And then we can rearrange now. We can say, okay, x comes before y in the alphabet. So I'm going to let the x's be at the lead and the y's trail behind. So how many x cubes do we have? Devin, how many x cubes are there?
2.
I think there's a 2 and then there's a plus a negative 1. So would that be a 1x cubed?
I thought you meant terms.
Oh. How many y cubes are there?
6.
6. When we combine those, we get 6 of them. Is that how we would see the answer in an answer bank? No. What would they do?
Take away the 1.
They take away the 1. They would clean this up and say, you don't really need that 1 there, so get rid of it. And we need to keep practicing how would they look when we're looking to see if we got the right answer. Okay. How about this last one? First of all, should we just go ahead, we have subtraction, then let's change it to add the opposite, and then we'll decide about rearranging it. Now, some of you are gonna, you're gonna be like, I do not need to change to add the opposite all the time. If you're being successful without doing that, that's totally fine. But there's a lot of us that are not successful without changing to add the opposite. So it shouldn't really be optional for us until we are better at this. Okay, what do you think? Do we have some rearranging to do? Okay, what do you want to rearrange? Pardon?
The M's and the N's need to be rearranged.
The M's and the N's need to be rearranged. Why?
Because they have like terms they can be
How many monomials are there here?
combined.
3. When we decide whether a monomial is like another monomial, if they're like terms, what do we look at? How do we make that decision? Jacob?
The value in the exponent.
The value on the exponent, that's part of it. We talked about this yesterday. What did we say about the variable parts of monomials and like terms? Why have we been putting, like in that previous one, we put those x cubes together and we put the y cubes together? Why did we do it that way? Nobody knows? Jacob?
Because they're the same variables
Oh, they have the same variable and to the same
to the same power.
power. The variable parts match exactly. So up here, when we decided we could put these x cubes together, it was because these parts behind the number factor matched exactly. So we said, oh, okay, well then there's 2 of them and there's a negative 1 of them, so that becomes a 1 of them, the x cubes. Okay, so let's look at ours, this one down here. Look at the variable parts of each of those monomials. Zero in on the variable parts of each of those monomials and tell me something, what's true or not true. Maybe your papers are something different than mine does, I don't know, but don't look at mine, look at yours. When you look at your paper and see, what can, look at, we said there's 3 monomials there, and maybe at this point, I should just take and go like this, I should say, okay, there's 1 of them, There's another one, and there's another one. Okay, zero in on those binomials and tell me something about, that's true about them or not true about them. Devin?
They're all the same.
They're all the same? Yeah, they all have the same variable parts. They're all m cubed n squares, right? They're all m cubed n squares. Kind of a funny variable part, but that's what it is. But they're all exactly the same variable part. So since they're the same, in reality, I only need to do what? Combine like terms. They're all like terms, aren't they? So we have 9 plus 5.
14.
14. Let's just do it, gradually here. So we have 14 of them when we combine the 9 and the 5. And then we have plus that negative 13, so they're still like terms, right? 14 plus negative 13, 1. So there's 1 left of those crazy m cubes, n squares. Would that be how we would see our answer in answer bank? No, what would they do?
Take out.
They'd take out the 1, and they'd say this could be written as m cubed n squared. There's our final answer. So the variable parts match exactly. M cubed n squared. What if there had been some m squareds n cubes? What if there would have been one of these? I'm just going to add this on, pretending it's there, but it's really not. What if we would have had this? Would that have qualified as a like term with those other 3?
No,
Why not?
they don't have the same exponents.
No, they don't have the same exponents. This is m squared and n cubed, not m cubed and n squared. So if that was there, it would not qualify to be one of the like terms. Okay, so any questions? Okay, let's go to the back. So there we were just adding monomials. Well, a monomial is a polynomial. But what if we're adding polynomials that are not just monomials? In other words, there's parentheses around them showing, because here's what they will do. To show that it is a polynomial being operated on with another polynomial or polynomials, they will put parentheses around them. So parentheses are showing the polynomials being added. Notice what I say here. Parentheses can just be dropped when it's addition. And then we'll just follow the steps we did to add monomials. So we have, what kind of a polynomial is that? Quadratic binomial. What's this? Quadratic trinomial. So we have a quadratic binomial being added to a quadratic trinomial. And since it's addition, we can really just ditch the parentheses and set up our addition of, and I'm going to change that subtraction in there to plus a negative 1m. Change it to an addition of a bunch of monomials. And then we'll just do exactly what we did on the front. We'll rearrange, putting the things that we know can become, I'm going to stick a 1 in front of that m squared there too. Putting them in the order they would actually go in standard form. So the m squareds would get to be first, the m's would be next, and the constants would be last. Do you have a question, Doug?
Okay, and those
Can you add what?
5 and 6.
Yep, we can. Right now we're just rearranging and putting the like terms beside each other. So yes, we can add. What parts can be added? You said the 5 and the 6 can be added. What else can be? The m squares can be added together. So how many m squares do we have altogether? 5. Anything to add together with that negative 1m? No. By itself doesn't have a like term. 5 and 6, 5 plus 6, 11. And now we'll just clean that up. How would this look cleaned up? 5m squared minus m plus 11. There's our final sum. Number 6, go ahead and do that one on your own. Following the steps, notice I give you enough lines to do a good process. Look at what the sign that's going on in between the parentheses, that tells you whether you're adding or subtracting. Really good idea. Count monomial to make sure you don't lose any along the way before you start combining the like terms. And 6 in the beginning, or before I even start combining my terms, now I see I still have 6, so all is well. And now I can start combining like terms. Okay, let's see if you agree with me, or you need to challenge me on something. So do we all agree on this answer over here, the cleaned up answer? Yeah? Okay. Okay, go ahead and try the other two on your own, and then compare with table partner, see how you compare. When there's more than one variable involved, don't be worried about standard form as much, okay? Checking it out with table partner to see if you guys agree. Because you may need to challenge me. You never know. You may need to challenge my answers. Your partner say, you know what, no, not right, ours is. Any questions, concerns? Yes, Jason?
Numbers that would be 8x plus
8x plus 8y. Okay, what do you guys think? Tracer wants to know, can't we let this one right here be 8x plus 8y? Right. And so, why not? Because I have the answer there and you don't want to disagree with me, you'd rather disagree with Chaser. Devin?
8. It'd be 8x plus 2y. This 7 is multiplying by what? Multiplying y.
Okay, so you said it can be 8x what?
Plus 2y.
You want it to be 8x plus 2y.
That's not what I had, but
You thinking that maybe that's a possibility? What do you think, class? What's true about like terms? What has to be true?
Had to be the same.
The variable parts have to be exactly the same. So is xy right here, in this right here, when we have xy, is that the same as an x and a y that are being added? No, because this is an xy that's being what? Multiplied. So this one matches up with this one because they're both being multiplied by each other, aren't they? So these two are like terms. The 10xy and the negative 3xy, they're like terms. This x that's right here doesn't have another one that just has an x, does it? An x variable part I'm talking about. Nor does this y have another one that has just a y variable part. So in reality, we cannot do either of these. No.
try.
We tried, but we can't do it. Okay. Anything else? Okay, then let me get your worksheet out to you.